Good morning. I am Sweta Sarangi and today I'm going to teach you about road materials. Okay. So in your course this is your third chapter. So in the previous chapter we have studied about the road geometric design or highway geometric design. So in this chapter we are going to study about the road materials. Like what are the materials we are used, what are the materials we are going to use in our road constructions. Okay, so a wide variety of materials are used in the construction of roads. These are soils naturally occurring or processed, aggregates, that is fine aggregate or coarse aggregate obtained from rocks, binders like lime, bituminous materials, and cement and miscellaneous materials used as admixtures for improved performance of roads under heavy loads and traffic. So, first of all, I'm going to explain you about soil. We know that soil, what is soil? Soil is the uppermost layer of the earth surface. Okay, so soil constitutes the primary material for the foundation, subgrade, or even the pavement for low cost roads with low traffic in rural areas. When the highway is constructed on an embankment at the desired level, soil constitutes the primary embankment material. Further, since all structures have to ultimately rest on and transmit loads to the Mother Earth, soil and rock also serve as foundation materials. Soil is invariably used after some process of stabilization, such as compaction and strengthening, by adding suitable admixtures for improving the performance of the road surface or performance of the road. Next is properties of soil. So there are various properties of soil like stability, incompressibility means if compression they suffer no significant volume change, permanency of strength at some at same state or place. Okay, then good drainage condition, easy of compaction, then minimum changes in volume and stability under adverse condition. So these are the various properties of soil. Next material we are using for the construction of road is stone aggregates. So stone aggregate or mineral aggregate as it is called is the most important component of the material used in the construction of roads. These aggregates are derived from rocks which are formed by the cementation of minerals by the forces of nature. Stone aggregates are invariably derived by breaking the naturally occurring rocks to the required sizes. A study of the types of aggregates, their properties, and the test to determine their suitability for a specific purpose is of utmost importance to a highway engineer. Next is functions of aggregate. So there are various functions of aggregate. First, it should bear the stresses occurring due to wheel load on the pavement. Based on the strength property, coarse aggregate are divided as hard, soft aggregate. So example of these hard, soft aggregates are morum, conker, brick aggregates, etc. It should resist the wearing action due to abrasive action of the traffic on surface course. So fine aggregate are sand formed by weathering of rocks. Next, the properties of stone aggregate: strength, hardness, toughness, durability, cementation, appropriate shape, adhesion with bitumen. So these are the various properties or various important properties of our stone aggregate. Okay. Next is our bituminous material. It is very important, and bitumen was used as a bonding and waterproofing agent thousands of years ago. However, the use of bitumen for road making picked up only in the 19th century. As the quest for fuels like petroleum to run automobiles grew and the distillation of crude oil emerged as a major refining industry, the residues known as bitumen and tar found increasing use in constructing bituminous surface which provided superior riding surface. Okay, so these are the three important materials for the construction of roads. These are the major materials: soil, stone aggregate, and bitumen. Then we are going to study about the properties of bitumen. So there are various properties of it, like workability, durability, strength and adhesion, cost effectiveness. It should have high ductility to avoid brittleness and cracking. It it has volatile constituents in bitumen, should not be lost excessively at higher temperature to ensure durability. So these are the various properties of bitumen. Next is tar. What do you mean by tar? Bitumen and tar, these are two different things. So tar is a black or brown to black, viscous, non-crystalline material having binding property. Due to its binding property, we are using this material in our construction of roads. This is therefore the other category of bituminous material. Tar is obtained from the destructive distillation of organic materials such as coal, petroleum, oil, wood, and peat. In the absence of air at about 1000 degrees centigrade, it is completely soluble in carbon tetrachloride CC14. It contains more volatile constituents than bitumen and is therefore more susceptible to change in temperature. Generally, tar is used for surface dressing on the wearing course since it has a good adhesion in damp condition. Okay, so it has good adhesion property, that is why we are preferring tar in our construction. Next is bitumen emulsion. So tar, bitumen emulsion and bitumen, three are different things, but these three have good adhesion property. That is why we are preferring this as our binder material. A bitumen emulsion is obtained by blending bitumen with water and an additive called emulsifier. The emulsified suspension contains dispersed minute particles of bitumen, that is oil, in water. In a bituminous emulsion, bitumen is the dispersed phase, minutely subdivided particles, while water is the continuous phase in which it is not soluble. The amount of bitumen to be mixed with water may range from 40 to 70% depending upon the intended use of the suspension. Next is cutback bitumen. Cutback bitumen is one, the viscosity of which is reduced by adding a volatile diluent. Penetration grade bitumen is required to be heated to a specified temperature to lower its viscosity before it is applied on a road to facilitate coating the preheated aggregate. To offset the need for heating the aggregate, cutbacks come in handy. Upon application, the volatile slowly evaporate and leave behind the original bituminous binder. Okay. Next is the most important test which we are going to do, California Bearing Ratio test. This is also called as CBR test. So California Bearing Ratio CBR test was developed by the California Division of Highway as a method of classifying and evaluating the soil subgrade and base course material for flexible pavement. So CBR test, an empirical test, has been used to determine the material properties for pavement design. Empirical tests measure the strength of the material and are not a true representation of the resilient modulus. It is a penetration test wherein a standard piston having an area of 3 in or 50 mm diameter is used to penetrate the soil at a standard rate of 1.25 mm per minute. The pressure up to a penetration of 12.5 mm and its ratio to the bearing value of a standard crushed rock is termed as the CBR. Okay. So in most cases, CBR decreases as the penetration increases. The ratio at 2.5 mm penetration is used as the CBR. In some cases, the ratio at 5 mm may be greater than that at 2.5 mm. If this occurs, the ratio at 5 mm should be used. The CBR is a measure of resistance of a material to penetration of standard plunger under controlled density and moisture conditions. The test procedure should be strictly adhered if high degree of reproducibility is desired. The CBR test may be conducted in remolded or undisturbed specimen in the laboratory. The test is simple and has been extensively investigated for field correlations of flexible pavement thickness requirement. Okay, so this is all about the California bearing ratio test. Okay, so in the next class I'm going to explain you about the test procedure. Thank you.